Hey guys, today we're going to talk about one of my favorite subjects and one of the most frustrating subjects because so many people have it frustratingly wrong. And when I get done talking about this, you will understand why it's so frustrating because it is insultingly wrong, embarrassingly wrong, and only you can only conclude that it's been done on purpose to send us down the wrong path into metabolic dysfunction and poor health. So we're going to talk about calories as they relate to the human metabolism. And to start off, I'll give away the ending. Calories have absolutely nothing to do with the human metabolism. And I'll explain why. Don't let your cognitive dissonance, you know, freak you out, because most people don't know anything about the human metabolism. They only know how to repeat calories in, calories out, first law of thermodynamics, blah blah blah. So the myth is that a calorie is a unit of measurement for the energy contained in our food substances. That's false. That's not what a calorie is. A calorie is a unit of measurement, defined direct measurement of heat energy. It was originally conceived, the calorie, as a way to measure the input-output efficiency of the steam engine. And then later on, some genius decided that such a simplistic method to measure a simplistic mechanism could be applied to the infinitely more complex human metabolism, even if you just took one single cell and compared it to a steam engine. It is ludicrously incomparable. It's way more complex, the human cell, than the steam engine. Um, So this fellow, I believe his name is Atwood, developed the bomb calorimeter, which is a vessel that you submerge in water. The vessel contains a food item, specific volume of food item, and then the vessel is filled with pure oxygen and sealed, and that food item is burned within a certain volume of water, and the temperature that water rises is the caloric value of the food, supposedly. Legally, this measurement can be off by plus or minus 20%, so it's completely inaccurate, completely unscientific. You will never be able to accurately measure your caloric intake, even if it were relevant to your metabolism. Why is it not relevant to your metabolism? Well, because calories are a unit of heat measurement, and the metabolic processes in your cells, the mechanisms, the energy currency that powers your cell functions is potential energy, not heat energy. It's two completely different forms of energy, two completely different processes. The heat that is released is a waste product of these metabolic processes. They have some function, but it has nothing to do with how you convert food into fuel. It regulates your body temperature. Most of it is lost to entropy. So again, heat measurement, heat energy has nothing to do with the human metabolism. It does not. You do not have the mechanisms in your cells to utilize heat energy. It utilizes potential energy, and what potential energy is essentially is it is the chemical bonds in the atoms that hold together your molecules, that create your molecules. These chemical bonds create molecules, and when those bonds are broken, which I'll describe later more in more detail, they release a relatively large amount of energy that the cells use to like contract a muscle or whatnot, some kind of function. Um, so, not all foods that you eat, not all macronutrients that you eat, are utilized by the mitochondria to create fuel currency. Um, Not all foods are bioavailable, first of all. We'll talk about that when we talk about poop. And for instance, carbohydrates, which are converted into sugar, um, are, are toxic in large amounts. A lot of people love their carbs. They don't believe this, but I'll explain how this works. Sugar causes a process called glycation. Glycation is the non-enzymatic binding of sugar to protein, which deranges and causes dysfunction. Imagine you're trying to run a race, a sprint, and a toddler runs over and grabs hold of your leg. and you're trying to run a race with a toddler grabbing hold of your leg, you can't do it. So that's a very basic description of glycation. The systems in your blood can handle glycation better than all of your other cells because there's always sugar present in your blood. Your homeostatic level of sugar is, if you're healthy, is typically about 1 teaspoon in your entire blood system. So there's always sugar there. There's always glycation happening there. Your epithelial cells in your blood vessels, your red blood cells and whatnot will reproduce at a quicker rate than your other cells. And there's also mechanisms that will keep the inflammation from becoming chronic. Uh, Mechanisms like cholesterol. Cholesterol is there to reduce inflammation. So if you consume a large amount of carbohydrates, that blood sugar will raise, which creates a metabolic emergency, um, especially when you have consumed more glucose, basically, than the mitochondria can take in and convert to ATP, which I'll describe later. So that because the non cardiovascular cells cannot handle the glycation the way the blood cells can, that sugar is kept in the blood, but it's still harmful. So the pancreas releases insulin, and the insulin clears the sugar out of the blood by converting it to fat, converting it to triglycerides, and triglycerides are basically a storable form of fat. There's no other use for it. It's just converted to triglycerides, and eventually it gets stored in your fat cells. So this is one way that the metabolic process has way more to do with hormones and what you eat rather than how much you eat. Although it is possible to consume a relatively proper amount of carbohydrates so that you're not consuming more carbohydrates than your body uses as energy. It's very possible to do that. People do it all the time. I don't recommend it because it has other harmful effects, but we're not talking about that today. We're just talking about how your metabolism functions. Proteins are almost never used as an energy substrate. They are used to build and repair structures. Very little of it is used as an energy substrate. Your macronutrient ratio has a lot more to do with with how many calories you're eating. How many calories you're eating in protein will have very little to do with even if calories were a thing, the calories in protein are not utilized in the way that you think calories are used to create fuel or energy. So measuring calories out is equally impossible. Different forms of exercise have different metabolic results, whether you're sprinting or jogging or doing high intensity interval training, powerlifting. They all have different metabolic effects on your body. You can also, if you also do it consistently enough, you will develop more metabolic efficiency, and in those exercises, that is completely impossible to calculate. So, calculating your total daily energy expenditure and your basal metabolic rate is, from a caloric standpoint, is basically useless in an exercise in futility. How many calories are in your poop? This guy Atwood that I described earlier actually tried to determine that, and it's so convoluted that I couldn't even describe it to you, and absolute nonsense. But 30% of your stool mass is actually bacteria, so almost like a third of what's in your poop is not even what you ate. And that begs the question, how much of what you eat is consumed by the bacteria in your gut? There's actually more bacteria in your body than there are cells that are you. You have to wonder, are you actually you? What is actually you? Because there's more that is not you than is actually you in your body. Um, So, what does the actual human metabolism do? How does it actually function? So, the human metabolism is, in its most simple form, the processing and breaking down of large molecules into smaller molecules. You get down to the glucose or the fatty acids. They enter the cells via their enzymes, their proper enzymes, transports. which converts both of them, either of them, into acetyl-CoA via different processes, and then acetyl-CoA enters the mitochondria, the Krebs cycle, the citric acid cycle, out of which ATP and other substances are produced with carbon dioxide as a waste product. ATP is adenosine triphosphate, so there's 3 phosphate atoms in this molecule, and when the cell needs to perform a function, one of those phosphate atoms is broken off, the chemical bond is broken, releasing a relatively large amount of energy, and that potential energy is utilized by the cell to perform its functions. And afterwards, you have adenosine diphosphate plus a phosphate atom. The mass balance equation has not altered. You have not lost mass. Even though you have released energy, you've not created energy. You have released energy, and you have not lost mass. The whole law of conservation of mass, you can look that up. There's the first law of thermodynamics, and there's also the law of conservation of mass. So you have not lost mass in the release of energy in your metabolism. Mass is never lost. Mass never becomes energy. All right, say it again. Mass never becomes energy. Never happens. You have ATP, 3 phosphate molecules, and then ADP, 2 phosphate molecules plus a free phosphate molecule. It's the same mass. It's the exact same thing. It's just broken the chemical bond, which has no mass. So, and then you have other processes like one of the reasons, there's always creatine in your body, but a lot of athletes will take creatine to get more creatine in there because creatine will take that phosphate atom that has been broken off from the ATP to create ADP, and then will reattach that phosphate molecule to the ADP to recreate ATP. So, it's this process of recycling, and if you have fat to lose, then what you're going to want to do is you're going to want to need more ATP than is in existence that is constantly being converted to ADP and recycled back into ATP, and you're going to want to kind of influence the body to use more energy substrates, fuel substrates to create more ATP than is currently in existence because you need more. And basically, the best way to do that is to tell your body not to store fat. And if you're telling your body not to store fat, and you need that ATP for more energy, for more fuel, then it will use the fat in your body because there is way more fat in your body than there is carbohydrates. That's why carb adapted athletes have to constantly consume carbohydrates in order to fuel their workout. So if they're running a marathon, they're constantly drinking Gatorade or whatever they drink, whatever they do to get their glucose in. Whereas carb adapted athletes can run mega marathons, 100 plus marathons fasted. They can run. There's a guy in Australia who ran 5 marathons in 5 days fasted without consuming any food, any substrate at all. He drank salt and water. That's all he drank. All he consumed was salt and water for 5 days, and ran 5 marathons and said he never felt better. So if your hormones are telling you to use fat as the fuel substrate, then you will lose fat. And if your hormones are telling you to store fat rather than use fat, then you will use glucose, and you will store the excess glucose as fat. It's a very, very simplified way of putting it. There's other processes involved, like the Randle cycle and whatnot, that can exacerbate the problem. A lot of people consume a lot of glucose and do not put on fat. I don't know exactly why, but a lot of people. But you are not going to put on fat, really, in a chronic manner unless you are consuming a lot of carbohydrates, because you are not going to store fat in a chronic manner unless you have an excess of sugar in the blood that needs to be removed because it is destructive. It's deranging. It's dysfunction. It creates dysfunction. So, as you can see, that has a lot more to do with hormones and your hormonal reaction to what you consume than how much you eat. So it's way more to do with what you eat than how much you eat. And the whole idea of eat less and move more is a ridiculous concept that has convinced people that they can consume the same things that they consumed, which made them fat and metabolically diseased, just eat less of it. And that is why not 1 in 100 people will try that and actually succeed. Um, and there's many reasons for that. First of all, it's miserable because overweight people are already starving. Their body is, that's why you're always hungry all the time, because you're not eating anything that your body can really do anything with, and it's telling you to give it more. And also, when you consume large amounts of carbohydrates, it spikes your blood sugar, creates that metabolic emergency. Your body releases insulin, and typically it overdoes itself. It takes out too much sugar. You need a certain homeostatic amount of sugar uh, to uh, to run certain metabolic functions, and then you have too low of blood sugar, and that creates hypoglycemia. It makes you hungry, dizzy, and sick feeling, and you have to eat again. If you ever have a bowl of cereal, you're hungry 45 minutes later again. That's because you haven't eaten anything that your body can do anything with, and that is totally hormonal. Your hormones are kicking in saying, feed me again, because you have not fed me enough. Whereas you eat a high fat, high nutrient dense meal, you can often go many, 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 many hours, even days without eating and feel perfectly fine. It is all hormonal, and it has nothing to do. I mean, yes, you might consume less mass eating a proper human diet, but that is not the deciding factor for whether or not you lose or gain weight or fat. It is almost entirely a hormonal process. So we'll recap real quick. Um, Calories are a unit of measurement of heat energy. Heat energy cannot be used by the human metabolism. We don't have the mechanisms for it. Therefore, calories have absolutely nothing to do with the human metabolism. Um, Different macronutrients have different metabolic influences on your body. Not all of it is bioavailable. Um, the caloric model doesn't account for how much mass you excrete. And by the way, that is the only way you lose mass is what you excrete, what you drop in the toilet, what you sweat out, what you comes out of your eyeballs with tears. You breathe out these gases. These have mass. You cut your hair, you clip your fingernails, you shed skin. That is the only way that you will lose mass, that you will lose weight, is through excretion. Again, energy, mass never becomes energy. Energy being a construct with no physical reality and no mass. So the mass never transforms into that energy. It's always mass. It's just a different form of the same mass. For instance, chemical bonds breaking, your ATP becomes ADP plus a phosphate atom, basically. Um, and that about covers it. I appreciate you guys watching, and I appreciate if you have any comments to make that you keep them mature and based on the science, not just based on your repeating what you heard a bunch of times and never really looked into. The internet has created a whole army of people who don't know how to have a mature adult conversation. So, I mean, I guess troll me in the comments if you wish, but I would be much more appreciated, and I would be much more amenable to discussion if you can try to describe how I am wrong from a scientific standpoint, where I am wrong from a scientific standpoint. I don't think you can. I think it's pretty irrefutable, unless I'm completely wrong about the way that the human metabolism utilizes energy. You can describe a metabolic process, a metabolic cellular function that runs off of heat energy. Knock yourself out. I'd like to hear about it. But that's it for today. I appreciate you watching. Give me a like and subscribe. I'm going to be putting out content more and more often, and I am immersed very deeply into biochemistry and cellular biology and physiology and all of the things that that can bolster my knowledge to be able to share with you, because it really, really fascinates me. So thanks for watching.